Hello, programmers. How are you? You cannot answer me. I assume that you're doing okay. I hope you are. Today we're going to continue talking about functions in JavaScript, and we're going to add on one more excellent piece of the function story, which is the idea of return values. Functions with return values, in some ways this kind of completes the picture that we need to have of functions. There's some more advanced stuff that you'll probably learn as you continue to work with JavaScript. But after we've talked about the basic idea of defining functions, the idea of having parameters with our functions, and the idea of return values, which is what we're going to talk about now, we kind of know what we're talking about with functions. So let's talk about this. Let's write a quick little program. Create canvas, as always. Probably should have prepared this earlier, but I didn't. I apologize. And let's use the random function. So let x equals a random position between 0 and the width, and let y equal a random y position between 0 and the height, and then we'll draw our classic ellipse at that location, x, y, and I'll make it 100 pixels. So if we go and look at this, we kind of know what the behavior is, right? Every frame, we're setting x and y to random positions on the screen, and then we're drawing an ellipse at that location. So we end up with a kind of freaky, I don't know what you would call that, confetti, extreme confetti. Maybe it's paparazzi's flash bulbs or something like that. The circle is being positioned in a different place every frame. So we get a funny dancing circle. So the thing I want to point out for today is we're using this function called random, but unlike most of the functions that we've been using, say like background or like ellipse, those functions just kind of do a thing and that's that. Ellipse draws an ellipse based on what we tell it and that's it. Background makes the background black and then that's it. Random goes away, works out a random number in the range you specify, but then there's one extra step, right? It gives it back to us. And that is why when we are calling random, we're assigning the result of calling random into a variable called x. We're doing that because random gives us something back. And what we call that in programming is we say that random returns a value. So we say, when we describe random, we say random is a function that returns a random number, in this instance, between 0 and width. So we can already see, because random is a great function, that this idea of a function that goes away and calculates something for us and returns the result can potentially be extremely useful. One thing to point out here, so right now we're using random in this way where we call the function and it works out its thing, returns the result, so let's say it picks the number, whatever, 250, and then we assign that number into our variable x, and then we use x down here. So there's a kind of a two-step process there. It turns out that if we wanted to, rather than that two-step process, instead of calling random and assigning to x and then using x, we could actually just call random where we used x here. So you can call a function where you want to use its return value. So random returns a random number, let's say it's 250, so we could actually just call random in the place where we need that number, which is the ellipse's x position. And we could do the same thing for its y position. So instead of having that sort of two-step process with a variable, we could actually just call the random function where we want to use the value it returns. So now, if we're reading this, we're saying we've got an ellipse, draw it at a random position between 0 and width. Random will take care of that and return the value for us. Ellipse will use that value. And a random position between 0 and height. Ellipse will use whatever value it returns. So you can do that, and you will see people doing that. One thing to think about is whether this makes your program more or less readable. Arguably, this is a little less readable, right? I think that in many ways, when it looked like this was actually kind of a nicer looking program. By spreading it out a bit, I think it's a bit more legible. You might see people arguing about whether it's more efficient to do it the other way, whether it's better for memory use the other way. I say pick the way that you think is best for your program in that moment that looks the best. Okay, so just because you can call a function inside here as one of the arguments to the ellipse doesn't mean that you should or that you have to. Okay, so random is great. Functions that return values, that calculate something and return a value, clearly they are helpful things. So we would want to be able to potentially do that ourselves. I mean, it depends on what we're doing, but let's say, just by way of terrible example, we want to be able to frequently convert between Celsius and Fahrenheit. In particular, we want to convert Fahrenheit temperatures to Celsius temperatures. Now, this is exactly the kind of calculation job that a function could be good for if it can return the result. So we want to be able to define a function that actually does that. So if we were writing a function to do this, we already know most of what we would need, right? So let's define our function. So we know we need the word function. That's always how we define functions. It needs a good name. Because I'm going to be converting something to Celsius, I'm going to call it 2 Celsius. There are lots of philosophies about naming functions. At least at the beginning, just try and have something that makes sense. Try to avoid too many abbreviations and try to describe what the function does in the name. That would be ideal. We know we need parentheses here. Will this function need any parameters? Well, yes, it will, because we need to tell the function what temperature in Fahrenheit it is meant to convert to Celsius. So it's going to take a variable, a parameter, which is like a variable. Could call it f if you're feeling very kind of and like you want to save lots of space. But I would argue that it's probably better to write out the full word Fahrenheit, right? So this would be the parameter that will contain whatever argument gets passed through, that is the temperature in Fahrenheit we are trying to convert. So that's our little basic function. We call this actually, the function signature. The thing that kind of gives you the name and the parameters of our function, if you care. So this is our function definition. Doesn't do anything. We know, or like I know, you might know the math that we need to convert whatever number is inside Fahrenheit to a Celsius. So let's declare a variable that we're going to store our result in. This would be the Celsius result of our function. And we're going to assign to it the math that we need. So to convert from Fahrenheit to Celsius, you take the Fahrenheit temperature, which is in our variable, our parameter there, you subtract 32, and then you multiply by 5/9. That's just what it is, it's just math. And this is one of those cases where functions can be useful, right? They can just do math for us so that we don't need to either work it out ourselves or explicitly put this little bit of math in our program all over the place. We can consolidate it into a function. So this is good. This does the calculation, and it works out what this Fahrenheit temperature would be in Celsius, stores it in this variable, but as yet, that will just be the end of it. And to Celsius, the function will then not actually give that back. It won't return it to whoever called the function. What we need is one extra step, and I've been using this word return constantly. That is because that's what it's called in programming. So return. We write the word return, and then we say what to give back. What are we going to send back to the person who called this function? Well, what we want to send back is the value inside the Celsius variable or parameter. A variable, it's not a parameter. So we did the calculation, we stored the result into our Celsius variable, and then we're going to return the value that's inside that variable to whoever was asking for it. This function doesn't really care who calls it. It just knows that its job is, you gave me a parameter, I'm going to convert the value in that parameter, which I'm assuming you gave to me as a representation of a Fahrenheit temperature. I'm going to convert it to a Celsius temperature, and then I'm going to give that value that I calculated back. Okay, and now this is a ready-to-use function with a return value, so we could use it up here in, well, let's maybe not use it in draw, let's use it in setup. There's no real reason to do it over and over again. So, for example, let's say that I want to calculate a hot Celsius temperature. So I know because 2 Celsius gives me back a value. Again, I'm going to probably want to assign the result of that calculation into a variable. So I'm calling it hot Celsius. And I'm going to call my function 2 Celsius. Oh, geez, that wasn't very good typing. 2 Celsius is the function, and I'm going to give it what I understand to be a hot temperature in Fahrenheit, 100 degrees Fahrenheit. It's a classic. Everyone's always talking in the US about, oh, it's so hot, it was over 100 degrees Fahrenheit, whatever. But I often don't know what on earth that means, so I'm going to use my function to convert 100 Fahrenheit. I know that my function is going to do the math on that, and it's going to return the Celsius version of this, which I'm going to then store inside hot Celsius for my later enjoyment. And in fact, I'm going to enjoy it right away. I'm just going to print it out to the console. So I'm going to say 100 degrees Fahrenheit is, and then I need to print out the value of that variable. So I'm going to use my template string. I'm using backticks around my string. So I use $ and then curly brackets. print out whatever was inside hot Celsius, the result of that calculation, and that would be whatever the temperature, sorry, and I'll say degrees Celsius. So that's going to kind of report back on the result, just so that we can see it. And obviously we know that the part of the point of functions is reuse, and again, part of being able to give parameters or arguments to our functions is reuse as well. So let's figure out a cold Celsius temperature as well. So we'll use 2 Celsius again, but this time we're going to ask for, like, what is 10 degrees Fahrenheit in Celsius? Again, it's not something I actually know. And we'll do the same kind of thing, 10 degrees Fahrenheit. Obviously, if we were using this in a proper program, whatever that means, we might be displaying this on the canvas or something, but it's faster in this instance to just look at it in the console. So I'm going to print out the value inside cold Celsius so that I know what it is. Okay, so then we're good to go, right? So we've called 2 Celsius twice with 2 different parameters. Each time it's taken that parameter, which has ended up in the Fahrenheit parameter, and it's done the calculation that you use to convert from Fahrenheit to Celsius, stored that in a variable, and returned it. When it has returned it, we've stored the result in our own variable, and then printed out the results so we can kind of see what it looks like. So let's go and check out the results of that. So over here in my JavaScript console on the right, we can see it's printed out 100 degrees Fahrenheit is 37.777, lots of sevens, 8 degrees Celsius. So there you go, that is pretty hot, 37 degrees, almost 38 degrees, pretty hot day. And 10 degrees Fahrenheit is negative 12 degrees Celsius. Arguably not as cold as all that if you're from Montreal, for example, but pretty cold for somebody from New Zealand, potentially. So that's fair enough to call that a cold temperature. So our function is what gave us these results, right? The function went away and calculated from being given 100 degrees Fahrenheit what the equivalent is in Celsius, gave it back, and then we used that result. Same thing for the negative 12.2 recurring. Wonderful. So that is totally a working function. It's like, it does its job. And this is a classic kind of function in that it goes away and it does some kind of mathematical calculation and returns the result. Random is a bit like that too. So are map and constrain, for example. They're just doing math on a parameter that you provided and returning the result. So this is a very common use of functions, but with return values, I should say. But there are other uses of functions with return values as well. And to look at a different kind of example, I'm going to turn to something I prepared earlier, just like a cooking show person. A little thing that I've called Circle Launcher. I'm just going to grab all of this code and I'm going to throw it into my script here so that we're running a different thing. Let's just go look at the behavior of this quickly. So it's a script where a circle kind of starts in the middle and you can see it launches off at a random velocity from the center towards the edge. When it reaches the edge, it's resetting back to the center. So it was a bit too much code for me to just sit here and type out in front of you. And you've seen this kind of example before, of course. So if we look at the code just quickly, we can see standard kind of a definition of a circle. That is the thing that's going to move around. I've broken this down into functions because we're talking about functions. So in setup, we call this reset function. What does that do? Well, we would go down and find the definition, which is here. And you can see that what reset does is it moves the circle to the center of the canvas. 250, 250. Would have been better to do that with the width and height variables, I'm realizing. And it sets its velocity to a random number between negative 10 and 10. That's why it launches off at both different speeds and different angles. So that's set up, so that's what happens at the very beginning, and then in draw, we color in the background, we move the circle, we probably already know what the code in there is, updating the position with the velocity. We check if the circle is off screen. In there we have an if statement that checks all of the different possible ways in which the circle can have gone off the screen on the X and the Y, and if any of them are true, that's why we're using these OR symbols here for them. We reset, same thing that we did before, and then we display the ellipse, the circle, by calling the ellipse function, right? So that's our overall program. So let's look at what we've got here, and let's look at one extra potential that we have for calling a function now that we know about what am I talking about? Sorry, now that we know about functions with return values. Gosh, that's pretty embarrassing. That's the subject of today's talk. So it's in here. So it's not obvious that this thing here could be a function, but if you think about it, this is another kind of calculation, right? This is the sort of thing, so we know that this whole thing can be true or false, right? Because it's got all of these individual things that might be true or false. Is circle x less than 0, or is circle x greater than width, or is circle y less than 0, etc. That's kind of it's calculating something, right? It's calculating whether or not that whole group of things is true or false. Because it's calculating something, it's a candidate to turn into a function. So if I wanted to turn this into a function, what would that function look like? Let's write it. So it would be a function, and what is this function kind of doing? What's it calculating? It's calculating whether or not the circle is off screen. So is the circle off screen? One way that we could characterize this function is we could call it circle is off screen. So because I've called the function this, we can maybe sort of tell it's a function that's going to tell us yes, the circle is off the screen, or no, the circle is not off the screen. That's what it's going to report back. And we can probably guess from that kind of language that what it's going to do is it's going to return true if the circle is off the screen, and it's going to return false if the circle is not off the screen. It's not going to do anything to the circle. That's still going to be handled by check off screen, but it's going to just handle the job of answering that question. So how would we do that? Well, inside circle is off screen, we would say if circle.x is less than 0, or circle.x is greater than width. Same thing, right? We're just checking that condition. Or circle.y is less than 0, or circle.y is greater than height, a typing challenge. If any of those things are true, then circle is off screen should say, yes, the circle is off the screen. So it should return true. It's saying, yep, that's correct. If none of those things are true, which is our else situation, then it should return false. Those are the two things that circle is off screen should do. So this is another example of using return values, right? It's a way of encapsulating, grouping together this question, this idea of asking the question, is the circle off the screen? And now, instead of having our if statement explicitly check all that stuff in here, we can say, let's make a variable, circle, well, let's just call this off screen. That makes sense. Off screen. And we're going to ask the question, circle is off screen. He said, typing cautiously so he doesn't get anything too wrong. So here we're asking circle is off screen to check, is the circle off the screen? It's going to return true if it is and false if it isn't. And we're going to store the result of that in this off-screen variable. And then we don't need this big check here in our check off-screen. We're just going to write off-screen. So if off-screen is true, we're going to reset. What is off-screen? Off-screen is the result of calling the circle is off-screen function. And what does that function do? It checks if the circle is off the screen, and it returns true if it is, and it returns false if it isn't. So did that really do anything? It actually added a bit of code, if we're being honest, right? It's added another if statement, another layer of if statement to our program. So it's made our code a bit longer, but it's made check off screen much easier to read. We now don't have to encounter this big list of conditions, which we may not immediately be able to read and understand. It's replaced that with a simple call to a function going into a variable. Circle is off screen, which makes a lot of sense for the function name. We can now read the function name and know, oh, it's answering this question. It's going to be in this variable. And then our if statement's nice, right? If off screen, then reset. That makes sense. That just is, we can write it out as if it's almost an English sentence. And in fact, as we discussed a little earlier, we can go one step further. And this is a case where it might be a nice idea to use a function rather than assigning to a variable. Instead of assigning to the off-screen variable, we could just call the function directly in the if statement. So if circle is off-screen, that goes and calls the function and either finds out true or false. The if statement responds to that. If it's true, it resets. If it's false, it doesn't do anything. Now this is even better, I think, even easier to read. If circle is off-screen, reset. This, again, is getting that much closer to just being something that you can read. And we've kind of offloaded the work of that question of what does it mean for the circle to be off the screen? What is that? We've popped that down here into its own function, which means we can also change what our answer to that question is depending on what we're doing later on. Okay, so this is an example, a different example, right? It's not a calculation of a number. Instead, it's a calculation of a kind of a situation, whether or not something is true. And that is another very, very common use of functions with return values, is we use them to kind of move pieces of code into their own named area so that our main code, our higher level code, like this function check off screen, is easier to read, more organized, easier to kind of manage. And I hope you agree that this check off screen function has been really improved by moving the logic about checking if the circle is off the screen somewhere else. Okay? So functions with return values are very helpful. They can do kind of mathsy calculations, which is super useful. If you've got math in your program, you want to kind of encapsulate into a function. But they can also do things that are more about checking the current state of the program. And they can do a lot more as well, right? There's a lot more that we can do with them. Here, I think the main objective is just to kind of see what they look like, understand the basic idea of returning a value, and then moving forward, we can try and use these things more and more often. Okay, so that is functions with return values. I hope that it was educational content for you, and I will see you in the next video. Stop recording.